For this lesson, we will continue to explore probabilities, building on what was shown in the first video. We will focus on calculating probabilities for more than one event, as well as addition and multiplication rules. When there is more than one event and you're asked to calculate their probability, the first thing you have to do is to determine whether events are mutually exclusive or not. Mutually exclusive events are events that cannot occur at the same time. Here's a classical example of a mutually exclusive event. If I ask you to find the probability of picking a 10 or a jack, there is no possibility at all that the card that you will pick is at the same time a 10 or a jack. So, since they cannot occur exactly at the same time, this is a mutually exclusive event. On the other hand, if I ask you to find the probability of picking a jack or a diamond, things are a bit different. In your deck of cards, you have 4 jacks as well as 13 diamonds. One of these diamonds is indeed a jack, so both events can actually happen at the same time if you pick the jack of diamonds. As such, this is an example of a non-mutually exclusive event. Now, the method of calculating probability, known as addition rules, varies according to whether events are mutually exclusive or not. If you have mutually exclusive events, the addition rule for calculating the probabilities is the following. Now, P of A or B is the probability that either event A or event B will occur. P of A is the probability that event A will occur, whereas P of B is the probability that event B will occur. A and B here refer to the 2 mutually exclusive events we were talking about before. Let's go back to our mutually exclusive example where I ask you the probabilities of picking a 10 or a jack. Again, here's the equation for calculating the probabilities of mutually exclusive events. Now, event A, which is picking a 10, has a 4 out of 52 chances occurring, whereas event B, picking a jack, also has a 4 out of 52 chances of occurring. So if we add both of these together, our total probability is 8 out of 52 chances of us picking either a 10 or a jack. Now, we should simplify this as much as possible, which means that actually we have a 2 out of 13 chance of picking a 10 or a jack from a regular deck of cards. When events are not mutually exclusive, the addition rule to use is this. It's a little bit more complicated, but not that much more so. Again, we have the probability that event A or event B will occur, the probability that event A will occur, plus the probability that event B will occur, minus the probability that events A or B will actually occur simultaneously. In our non-mutually exclusive example, you are asked to calculate the probability of picking a 10 or a diamond. Indeed, if you were to use the other rule, you would count the possibility of picking the 10 of diamonds twice, once with the 10s and once with the diamonds. So you do need to correct this issue by removing one of the 10s. So here again is our equation for calculating the probabilities of non-mutually exclusive events. Put into numbers, event A is 4 out of 52 and event B is 13 out of 52 minus that extra 10 of diamonds. So 4 out of 52 plus 13 out of 52 minus 1 out of 52 gives us our final answer, 16 out of 52, simplified as always to 14 out of 13. These addition rules can also be used if there are more than 2 events. In this case, you must simply adjust the formulas. For mutually exclusive events, you simply have to add on the probabilities of the additional events. There's no limit to this. For non-mutually exclusive, slightly more complicated, but all you have to do is, again, add on the probability of the additional events and then subtract any probabilities of events occurring together.